Okay. Thank you very much for the opportunity to speak today. Excited to be here. My name's Reid Wilkinson. I'm the customer success leader for Weir Motion Metrics, as was just mentioned. And today I'm going to talk you through how we're helping clients improve surface pit mine efficiency through a shovel-based payload monitoring technology. And that overall helps us optimize both load and haul efficiency and energy management on that side. So just before we kind of break into the logistics of it, I wanted to touch on the history behind Motion Metrics quickly. So Motion Metrics as a technology vendor in the mining space has been around just north of 2 decades now. And we were recently acquired just back in 2021 by the Weir Group. And overall, the kind of mission that Motion Metrics employs is to put smart computer vision systems to help mines operate more safely and efficiently. So what that actually means in kind of a practical sense would be that we install machine vision systems in different areas throughout the mine to mill process and use that to do both incident detection and avoidance and data collection, which we then return into actionable insights to help drive continued efficiency in that entire process. In terms of the footprint of Motion Metrics, it was originally founded in Canada, if you can't tell from my accent here. But overall, we've spread out quite a bit over the years, and especially with the Weir Group coming in for purchase, there's quite a bit of resourcing and funding that was associated with that. So you can see we have a fairly large global footprint here. We have customers in over 70 countries on a global basis, over 70 mines worldwide. We've installed our equipment on over 400 pieces of HME in the form of shovels, excavators, cable shovels, front-end loaders. We have over 200 portable devices operating in the field, and we've just recently started breaking into the aggregate or quarry market as well. So you can see we have over 10 installations or 10 clients on that side as well now. In terms of Motion Metrics kind of portfolio here and what we look at overall, there is quite a bit of technology that goes directly on the HME piece. So you have the shovel metric system, which might be a little bit more of the focus of the talk today. Which goes directly on hydraulic face shovels, cable shovels, and hydraulic backhoes, or excavators, as you guys call them down here. We have a similar technology on front-end loaders. There's a portable handheld device, and then further downstream, more on the data analytics side, we have a truck's tray scanning system in the form of truck metrics, and downstream from that, a belt metric system as well. So looking past that, all of our data gets collected and then sent up to a centralized platform in the form of Metrics Manager Pro, where our clients are able to access that, integrate it directly back into their operations, and also generate user insights based on that. So with that, I wanted to touch on Shovel Metrics Gen 3 in particular, which is the piece of technology that we're using to accomplish this payload monitoring solution to help drive that load and haul efficiency. So overall, Shovel Metrics Gen 3, if you haven't heard of it, it's a pretty broad solution, can quite do a broad range of things, but overall it's kind of a complete bucket monitoring solution for, again, all types of shovels and excavators. And we use artificial intelligence running aboard that system to drive safety, energy efficiency, and productivity, as you'll see as we go through here. In terms of what that technology can actually do at a higher level, again, there is quite a bit of functionality surrounding it. I don't think we're going to dive into all of it today, but you can see kind of some of the snapshots here of what's actually capable with it. We can do GET loss detection, GET wear monitoring, particle size analysis, which we feed back into drill and blast processes to drive continuous optimization there, oversize detection and diversion. There's blind spot reduction for the operators that have the system available in the cab, embedded video recording, and again, the focus of today's session, which is the payload monitoring feature. And again, as with all the Motion Metrics products, these all connect to the cloud platform in Metrics Manager Pro. And you can see a little bit of the hardware associated with the system as well. So we have an onboard computation unit, stereo vision camera, which is kind of broken out on the right-hand side of the slide here, where you can see both the color, high-res vision that we get of the bucket, as well as the 3D profile that we get to return additional information there. And then the in-cab display, automated lens cleaning unit, stuff like that, that helps keep the system directly interacting with the operator and running in the long term. So looking at payload monitoring in particular, it's kind of broken into a few key areas here. First and foremost is that it's really important to get feedback directly to the operator. So we have a in-cab screen that gets, again, that real-time feedback to the operator on a bucket-by-bucket basis. So you get the individual bucket values in terms of the weight associated with those. You get that also on a truck-by-truck basis. And then also associated with that kind of graphical user interface that the operator can interact with, you get audible visual alerts. You get indicators that can help the operators adjust individual bucket loads on a case-by-case basis. And then also we're gathering quite a bit of performance-related metrics along the back end, which we can use to drive continuous optimization as well, as we benchmark individual operations against each other. And then as we integrate directly with our client systems in the form of FMS or fleet management systems, we'll get the truck in and truck out information so we can see varied payload compliance targets, this type of information, and then also tie that reporting back automatically directly into the operation on that side. And overall, the goal of implementing this technology is really towards consistency and efficiency. So we kind of have this one solution, does quite a bit, but on the payload piece, we're really looking to make sure that we're consistently hitting payload compliance targets on a truck-by-truck basis. You do get that bucket-by-bucket measurement that allows us to do some further optimization in the form of optimizing pass matching to actually fill the individual trucks. And one kind of more benefit you might see with this type of technology is that you only have one payload system for a broader range of equipment. So calibration and maintenance intervals are kind of reduced compared to what you might see on individual truck scale basis. So with that, in terms of the functionality, I don't think we'll dive too deep into it, but you can kind of see an overlay of what that would look like directly on the shovels. We use a combination of kinematic sensors and hydraulic pressure sensors, and then onboard algorithms to be able to calculate the payload on a bucket-by-bucket basis. And then this is just kind of a quick demo of essentially how this would work in the field. So the operator has a little bit of a view on the payload metrics on the side here. You can see he's getting the the bucket load information gets carried over. You have a tonnage target, and as he's actually going to dump that into the tray here, you can see that load gets transferred over into the tray indicator, and then his overall target would go down as well. So overall, again, you get that kind of bucket-by-bucket real-time feedback to help optimize on that side, and then also the back-end metrics that we're collecting to be able to optimize things like pass matching on a truck-by-truck basis. In terms of what the operator is able to see in the cab, there are kind of two configurations. If they have the camera system installed, they will see kind of the 4 views around it, and generally you can get some nice views surrounding that for blind spot reduction for the operator. There is the additional alarm-based functionality associated with this type of system, but the payload reporting portion is kind of on the left-hand side where you get your truck capacity, your tonnage targets, your individual bucket capacity, and how much is in the truck tray currently, and then some manual cleanup functions as well. Or if they didn't have the camera system, or if we just wanted to see more detailed metrics, there's kind of an alternate view here where you can see more information, instantaneous payload stuff, dig rate. You can throw alarms from here as well if an operator might exceed instantaneous dig forces that we should be seeing, and then other back-end information that we're gathering in terms of historical payload reporting on a bucket-by-bucket basis and truck-by-truck basis, and other operational practices that we can use to compare and benchmark against individual operators. So overall, hopefully that gives a bit of an overview of how the Shovelmetrics payload monitoring system actually works. In terms of the challenges that we're actually hoping to address through this type of technology, there's kind of 2 main ones, but they stem from a very similar issue of us not consistently hitting that payload compliance target. So overall, you're going to see decreased productivity when you're underloading trucks. Essentially, you've wasted a bit of a trip if you're loading to 90% as the truck goes out, drives all the way down to the operator, drives all the way back without carrying as much material as it could. You can also see a similar instance if you're overloading. So you can see reduced truck speed if it's governed to a shorter gear range because it's overloaded. And even past that, you can see safety concerns, premature wear on tires, engines, truck beds. And again, as you get into that severe overloading space, you can get into concerns surrounding operator safety and also warranty issues and also climbing maintenance costs associated with that. Inside the market, there is truck-by-truck scale reporting as well, which is quite a common technology that we've seen in the field. Kind of the difference there is that typically as those are pulling away, that's when you get the most accurate reading, rather than when the the shovel operator's actually loading into the truck. So they don't get that real-time feedback to be able to see that. And of course, with visual payload estimations, you're not going to get kind of what you need on that side to reliably hit payload compliance targets as material density changes. So the solution that Motion Metrics has put forward is the bucket-by-bucket and truck-by-truck payload reporting system. We have the on-screen metrics that allow the operators to hit this consistently in terms of load distribution and payload compliance. We're able to increase productivity and eliminate the underloading concern. We're able to prevent overloading and the risks of damage, safety, and warranty concerns surrounding that. And then, as kind of touched on before, we have all this information that we're gathering on the back end that we can do to, or use to analyze against individual operators, find best practices, and do targeted retraining based on that. So all of that ties back into the cloud reporting platform where you get individual productivity metrics. We can tie that directly back into the operational database for our clients. And then also, again, you can kind of benchmark individual operators on a case-by-case basis. So you could look at, why is operator 27 taking 8 seconds to get through the bench face? Does that have to do with the engagement angle when operator 25 is only taking 6 seconds? So with that, hopefully you have a good understanding of kind of the technology itself, payload monitoring, what we're aiming to address through the implementation of that in the field. And I just wanted to touch on this in a practical sense. So what are we seeing in the field? How are the customers using this? And what are the results we're able to achieve with that? So we're going to look at a 3-phase case study here with one of our partner mines. It's a South American copper mine in particular. And the focus for this study in particular was on an existing installation that they already had, a CAT 6020B, so that backhoe variant. It's a bit of a smaller machine, but overall the principles kind of carry out. And again, kind of 3 phases that we were looking at. So first and foremost, we wanted to establish the accuracy of the system. Are we sure that what we're reading as 20 tons is actually 20 tons? Phase 2, we wanted to look at, now that we've ensured that the system's accurate, do a baseline performance of the operators relying on their old inbound or built-in truck bed system, VIMs, and then finally turn on the system with the display, conduct some operator training, ensure they've adopted it, and see what that performance difference is from a loading perspective once it's actually enabled. And overall, the goal here was to quantify the truck compliance performance and individual operator performance before and after the adoption, as well as also ensure that we're operating within accuracy. So just up front, we can look at the accuracy portion, kind of along the bottom of the piece here. You can see the scope that we did to validate the accuracy in this instance. So we had 3 different operators load across 32 individual trucks. Each truck took roughly 12 to 16 buckets to actually fill based on the individual pass matching capability of those operators. And as we analyzed that against a weighbridge which the client brought on site in partnership with us, which is kind of the gold standard for being able to evaluate payload and truck calibration inside the industry, we saw an average error of only 2%, which is really tight. The client was really happy with that. We were really happy with that. And the standard deviation across that one was only 1.4%. So again, really tight error. The max data error we saw across the entire set was 4.5%. And we believe that was primarily attributed to carryback conditions associated with the truck loading. So overall, we saw really good error margins across there. We were happy, satisfied that we were able to reliably achieve the results that we were striving for. And just for comparison's sake, we did look at the onboard VIM system that they were running previously as well. And the average error we saw across those was 5.5%. The standard deviation was quite a bit wider at 14.1%. And then the max error on the entire data set was 66%. So this ties into maintaining a significantly larger truck fleet and the associated maintenance challenges with that, seeing systems fall out of calibration compared to just one operating on site. So after we enabled the system, we pretty much had it running in the background. We had ensured the accuracy based on that previous study that I just shared. And then we had our payload system running, but we actually turned the operator screen off. So we were able to do this data collection, and we ran a 419 truck study, split roughly evenly between having the screen off and then conducting operator training and having the screen on where they could see and receive that feedback in real time. And you can see the comparison here with the green kind of on the left-hand side here, representing the VIMS payload system and kind of the consistency of density distributions that they were able to achieve. And then on the right-hand side, the truck fill that was able to be achieved with the Shufflemetrics payload system. And the mine had set a payload compliance target of 243 tons. This is based on the 10-10-20 CAT rule, which pretty much means that 10% of the trucks in your fleet can be overloaded up to 10%, and no trucks can be overloaded over 20%. So they'd set these targets to try and boost overall productivity, as they'd seen drops on that side without violating this rule from the OEM. And you can see the kind of mean payload targets that we were able to hit through operator performance was 93.6% when they were using the VIM system beforehand, with the payload system reporting in the back end from our side, and a standard deviation of 12.9%. And then as we switched that payload system on from our side, we saw that boost all the way up to 97.6% with a standard deviation of 11.5%. Or if you translate that out into OEM tonnage, that was 102.7% or a 12.2% standard deviation. So overall, really good result. We saw that the payload distribution was tightening up quite a bit as the operators were adopting this system. And kind of the key result I would point to here is that the average truck fill improved on a case-by-case basis by 6.1% across the duration of this study. So pretty strong result, at least from the bucket fill analysis and truck fill analysis portion. After that, we also wanted to look at haul truck loading time. So overall, there was maybe a little less of a discrepancy here, but still a significant change as we turned that system on, having it collect data in the background initially, and then coming online after the fact. The average loading time while they were running on the VIM system was 8.2 minutes with a standard deviation of 2.3. And then the average loading time with the shovel metrics payload system was 7.9 minutes with a standard deviation of 1.5 minutes. So again, seeing improved efficiency, tightening up of the overall distribution there. And kind of the key result we could point to here was roughly 3.7% improvement in average loading time. And primarily this would be attributed to the continuous feedback loop that the operator's getting in the cab, the additional kind of competitive nature we saw between operators, as well as they understood they were going to be benchmarked against each other a little bit, but also with the bucket by bucket reporting in this instance, we were able to see better pass matching, which led to overall reduced cycle times to fill that truck up, especially with it being a smaller excavator. Again, you saw kind of 12 to 16 cycles per truck earlier. If we can drop off one of those cycles, it's a pretty significant improvement there. Final piece of the study that we looked at here was surrounding specific energy and emission. So on the chart here, you can see kind of a distribution of the specific energy that we reported out for the haul truck to move tonnage downstream. So it's reported in terms of kilowatts per kilometer ton, depending on the haul truck circuit. And we use the fuel rate burn sensors inside the trucks to be able to calculate this out. And overall, we saw a pretty good improvement here as well. So on the VIM side, before we implemented the shovel metrics payload system, roughly 1.01 kilowatt hours per kilometer ton with a standard deviation of 0.16. And then on the shovel metrics payload side, once that was turned on, 0.99 kilowatt hours per kilometer ton with a standard deviation of 0.05. So overall, again, seeing better result, better efficiency, tightening up in that instance. And a lot of this can be attributed to just the trucks running more efficiently, using their haul truck pathing more efficiently, carrying the right amount of material upstream. And the kind of the key result I would point to here is that we improved the average specific energy by 2%. So overall, just to summarize the case study and kind of the approach that we're taking to driving load and haul optimization inside the space, we did have a 2% error reading, which for us, we felt comfortable, and the client felt comfortable that we were able to repeatedly and kind of consistently achieve this target. We saw average truck fill improvement a significant amount by 6% or 6.1%. We saw average loading time improve by 3.7% and average specific energy reduction of 2%. And overall, this is a really great space to be in. It might seem like kind of marginal gains on paper, but comparing this out to overall productivity, we're able to see a really big boost, help the client hit their targets on that side. And if we're kind of in an operation where maybe they're already fully saturated and don't need to push more material downstream, then you can start to look at using your mobile equipment more efficiently, maybe parking a truck or two to be able to hit that same payload and production target with the same amount of equipment, just by employing digital technology to help with that efficiency. So with that, thank you very much. Appreciate your time. Hopefully it was insightful, and